Hello everybody and welcome to another episode of Math with Mr. Emond. Today we're going to be finishing up our unit on systems of equations. We're still solving them algebraically. We've already learned about solving them using substitution methods and elimination methods. We've practiced quite a bit. We've done it in different ways. And now I'm kind of leaving it up to you. So you could solve it using any method. So I'm going to go ahead and try this one out here. So we have y equals x squared minus 4, and we also have negative 2y plus 2x squared minus 8 equals 0. So the first step of solving any equation like this is to think, what's easier, substitution or elimination? Now I can see I've already got my y value isolated, so I could take this, y is equal to this, and I could just plug it in there. That seems pretty easy. The other thing that I could do is I would multiply this whole thing by 2 so that my y's have the same leading coefficients. And then I would have to FOIL this out and then align them properly, so I'd have to move them around, and then I would have to eliminate. So hopefully just thinking in advance will tell you that this is probably easier. So let's do this. So we have negative 2 times y, which is x squared minus 4, and then plus 2x squared minus 8 equals 0. And this is going to give us negative 2x squared. Negative 2 times negative 4 is plus 8, plus 2x squared minus 8 equals 0. And I'm noticing negative 2x squared plus 2x squared are going to cancel out, and 8 and negative 8 are going to cancel out. And that leaves us with 0 equals 0. What does that mean? Well, that means that 0, okay, what it means is that there's an infinite number of solutions. That's what that means. Whenever you get 0 equals 0, that means that there's an infinite number of solutions, which means that they overlap. And let's just kind of prove that for a second. Let's take this. Let's isolate y. So we're going to have 2y equals 2x squared minus 8. Let's divide everything by 2. So y equals x squared minus 4. And now if I look at this and this, they're exactly the same thing. So the quadratic equations were technically the same thing. So, I mean, we could graph them, right? And the first one would look like this, and the second one would look like this. They're right on top of each other. They're the same thing, right? And so every single point is a solution. So when you get 0 equals 0, that's an infinite number of solutions. I want to talk about something else. If when you're solving for them and you don't make a mistake and you get something like 4 equals 2, what does that mean? That means no solution. 4 equals 2, 7 equals 0. If like the numbers don't align, yeah, that's no solution, okay? All right. Verify our solution. Well, I don't think we need to do that, right? Because I know what this looks like when I graph it, and I know what this looks like when I graph it. It looks like that, okay? Let's not verify it. How about you give this a shot? So why don't you try this one out, solve using whatever method you like, and come back and I'll have the solution waiting for you. Okay, welcome back. Let's take a look at the solutions. So, the first thing that I did is I just looked and I saw I already have negative y and negative y there. So if I subtract them, that will be eliminated. So that was the easiest and quickest method. It was already aligned for me. So then I did 6 minus 4 is 2, or negative 1 minus negative 4 is plus 3, etc. And then I factored and I found these two x values. Okay, now I needed to find the corresponding y values. So I first kind of isolated y to make it a little easier on myself. And I plugged it into this one here. And I found when x is negative 5 over 2, y was 41. And so that was my first point. And then I did it again for when x is 1. So I plugged that in and I found y is 6. So there's my second point. Now, to verify it, I verified graphically because it would be a little quicker than verifying algebraically. Okay, so let's take a look at analyzing this graph. So let's find the point of intersection. I can see one of them is here, and I find the point to be 1 and 6. So that's point 2. Now I'm going to have to kind of look at this one. So I'm going to scroll, and it looks like they're intersecting somewhere over here. So I'm going to analyze, look for an intersection. I'm going to start a little further, and there we go. And it highlights negative 2.5 and 41, which is 0.1. So I can verify that these are indeed solutions. Let's move on. All right. Modeling. These are my favorite questions for sure. So here we have Mike hitting the baseball, and it travels on a parabolic path. John's in the outfield, directly in line with the path of the ball, and he runs toward the ball and jumps to try to catch it. And jumping is also going to be parabolic because gravity is pulling you down while you're accelerating forward. So in both equations, x is the horizontal distance in meters from the home plate, and h is the height of the ball above the ground, again in meters. And so we have these two that are given to us. So this is the path of the ball in flight, and this is the path of the jumping player. Solve the system algebraically. All right, this looks fun. Let's give it a shot. How am I going to do this? I could... Oh, why am I even contemplating? This seems like a no-brainer now. So my h values are both 1. Let's just eliminate. There. Okay. So let's make sure that we have them lined up. I'm going to add a plus 0 here. Okay, let's subtract. So h minus h is 0. Now we have negative 0.1 minus negative 1. So that's plus 1. So that's going to be 0.9 x squared. And then 2 minus 39 is going to be negative 37x. And 0 minus negative 378 is going to be positive 378. So there we go. We solved the system algebraically. Now we need to factor this. Yeah, good luck. I'm not doing that. I'm also not going to complete the square. I'm going to do the quadratic equation. Okay, so negative b, which is negative 37, plus or minus the square root of b squared, b is negative 37 again, squared, minus 4 times a, which is 0.9 times c, which is 378. So there we go. Over to a 0.9. All right, let's go ahead and solve this. And again, there's a little trick I'm going to show you later, but for now, we're just going to do it the old-fashioned way. Negative 37 squared minus 4 times 0.9 times 378 equals. That's 8.2. Okay, so this is 37 plus or minus 8.2. Well, the square root of 8.2 over 2 times 0.9, which is 1.8. All right, let's try that out. So we have 37 plus the square root of 8.2 divided by 1.8. So there we go. So we have our first solution. X equals 22.1464. Okay, let's find our second one. What is it going to be? We just have to take this and change it to a subtraction sign and solve. So there we go. It's 18.9647. So these are our two. Now we need to find the corresponding y values. So we're going to plug these into one of our equations. Let's just do that in our calculator because it'll be a little faster. So I'm going to copy this and I'm going to plug it into, let's say, the first one. So we have negative 0.1 times x, which we found to be that, squared squared plus 2 times the thing we found. So this is equation 1, right? And let's see what it's equal to. That. So our first point is 22 point, let's, does it tell us to round to a specific number? Not really. So let's round to 2 decimal places. 22.15 and negative 4.75. Okay. Point 2 is going to be 18.96 and what? So we're gonna copy this, paste it there. Okay. Now we're gonna copy this and we're going to replace that part of it. All right. What is it equal to? 1.96344. So 1.96. All right. So we have our 2 solutions here. We need to verify them still. And so we're going to graph it in a second and verify. But before we do, we started with this equation here. Circle it for now. We started with that equation there. I want to show you something. So if you type in solve, you can see it's italicized. When letters are italicized, it means your calculator doesn't know what to do with them. But as soon as I type in the full word solve, you can see it's unitalicized. So it knows this is a function in the calculator. And now I can type in my equation, 0.9 x squared minus 37x plus 378 is equal to 0. So there's my equation. And then I'm going to put a little comma here. And this is telling it what I'm wanting it to solve for is x. And there we go. I hit enter and it pops out. It does the quadratic formula basically for me. And you see here 18.9647 and 22.1464. So a little trick for you. If you want to just verify that you did the quadratic equation correctly, this is the way to do it, right? And then you know for sure that you solved that correctly. Remember, in my class, I'm still going to want you to show your work. But yeah, this is quite the shortcut, right? Just to, in order, not shortcut, but a shortcut for verifying that you didn't make mathematical errors. Now that we have these two solutions, we still need to verify them. So let's go ahead and get rid of this stuff. And let's graph them again, because it's just much faster to do. So negative 0.1 x squared plus 2x was my first one, and it's a very wide parabola, as you can see. And let's do the second one. It's negative x squared plus 39x minus 378. And so, oh, I can see a point of intersection, 2 points of intersection right there. All right, so I'm just going to move these away so that we can see our solutions. Menu, analyze, graph, intersection. Let's find this one, 19 and 1.96. So that's this one. So that's verified. And let's verify our next one, analyze, intersection, and 22.1 and negative 4.75. And there we go. So those are correct. Now it's going to be your turn. And this is the last problem of the unit. So go ahead and try this out. When you are done, come back and check the solution and I'll have it waiting for you. See you soon. Okay, welcome back. I have the solution ready for you. Let's take a look. So we have two equations. And the first thing I did is I isolated y. And that's because I just looked and I saw, oh, these have beautiful coefficients where I can eliminate them. So I already had that plan before I went to this step. And of course, I'm going to subtract them. And when I do, you get this, 3x squared minus 27, which you can solve to find x equals 3 and negative 3. And of course, when you plug those in, you're going to get negative 192 and 48. And so you have these two solutions. And then, of course, you want to check your work, right? So you would probably graph it, and then you're going to analyze your graph and look for the intersections. And I can see one of them's right here. 3 and 48. And the other one I'm going to have to go this way for, so it might take you a little bit to find that. And it looks like it's somewhere over here, so let's give that a shot. Intersection between these 2 points, there we go. -3 and -192. So there we verified our solutions. That is it for the unit. Hey everybody, you can like, follow, and subscribe to my social medias right here to get notifications as soon as new content is uploaded. This video concludes our learning unit. You can find the playlist this video was in right here and click here for the next unit that we'll be covering. Thanks for watching and keep learning, everybody. Bye-bye.